start recording over here. Okay. So I'm going to be recording on both Zoom and, over here. I'm going to be recording on both Zoom and on the second screen, so just be aware of that. So, welcome to this, I guess, short session on ENDG 233, programming in Python, and I'll try and go through as much as possible within these short 2 hours about the basics of Python and why it is so different. And by the way, just do know that this is just essentially the basics. It's not meant to teach you anything about, what do you call it? It's not meant to teach you how to code in Python. That stuff you're going to have to learn on your own. However, if you do run into any issues, don't hesitate. Just just simply contact us in the ESS or contact the professor, or just hit me a message on the 2025 server. Either one is fine. So with that, without further ado, let's begin. Let's go into the basics of Python and why it is different. Now, and when it comes to most other languages, back in the day, before, most languages were, I suppose, low-level languages, and there's a difference. And yeah, I guess we should start with that. What is Python, essentially, whether if it's low level or a high level, what are high level or low level languages? And essentially for that, a low level language is described as a language that is described in a very similar way to machine code, essentially. So any code that is essentially written very close to machine code, and by machine code, I mean very basic stuff like assembly. Assembly is definitely a low-level language because they're literally telling the processor what to do. And there's a couple of others, I forgot the names, but there are plenty of low-level language. They have their benefits in the sense that you have direct control over what you can do, and with that you can do a lot of different things, essentially. You can control the speed of your processor, you can even decrease it, increase it, who knows what else, because it's up to you. You have full control after all. Now, high level languages usually have an interpreter in between that translates the information into machine code. So let's say you have a high level language such as Python. Yeah, Python is a high level language and it runs through an interpreter. So what happens is you write your code in Python and it gets interpreted by a compiler, or an interpreter in this case, and then it compiles the program and gives you the output. And what makes Python a bit different compared to most other programming languages is the sense that it is the fact that it runs through a interpreter. Most programming languages before usually ran through how do you say it? Usually gets run through a compiler, as in the code is compiled up into a set of instructions for which is then translated into machine code, and after that the machine code is fed through the processor and the computer does its job. An interpreter does essentially the same thing. However, it's different in the sense that it doesn't compile the stuff, but rather interprets the details directly. So it's both compiling and doing the translating into machine code part at the same time. So that's why Python is a bit different. In many ways, this may cause Python to be a bit slower than other languages because it's ran directly through an interpreter. However, it's not that slow unless you have like a massive program, like maybe 2,000, 3,000 lines or 4,000 lines, those sort of programs. Then Python may be a lot slower. Yes, Yash. Well, you may. What do you want to say? Yeah, indeed I am. Oh, I forgot to mention, yes, indeed, I am recording this lecture. I am recording it through OBS Studio, so that's why you're going to have a quality lecture video. Oh, right. Desktop audio is turned off for audio OBS. I guess I'll turn it on. So, for those of you who didn't notice, Yash, a friend of mine just apparently raised his hand in order to ask a question, whether if it was recorded or not. And yes, indeed, this session will be recorded. So where was I? Yes, interpreters. In terms of interpreters, because Python is ran through an interpreter, it may be a bit slower than your average, I suppose, C or C++ program. Whereas in C or C++, the program is directly, run through a compiler, and you can just instantly run the exe file directly once the program has been compiled. So in that sense, the compilation may take a bit of time, but the overall program itself will be a lot faster. However, because Python is ran through an interpreter, every single time you want to run it, you're going to have to run that code every single time. And since you're running that code every single time, it's going to be a bit slower if you consider timings, obviously. But at your level, you don't have to worry about runtime, but it's just a small little tidbit you might want to have when you're, going into your future years, planning to, go into programming or software engineering, whatever you wish. So that is how Python is a bit different. Another difference as to why Python is a bit different is the fact that it doesn't use the semicolon. Now, if you're new to programming, then you may know that, then you wouldn't know this, but most programming languages feature the use of a semicolon at the end. And the semicolon essentially tells the compiler, or the interpreter in this case, well, Python doesn't use a semicolon, so it's not the interpreter, but it usually tells the compiler that, okay, the line has just ended, we'll move on to the next line. And that is exactly how most programming languages usually separate their code bases. So you can, in C or C++ or many different programs, you can actually have an entire code just written in all one line. You can have like thousands or even hundreds of thousands of characters just written in a massive line, and it should still be understood, because like the compiler would understand it. A human could have a hard time understanding, because one single line, pretty damn difficult to understand. But yes, the compiler could understand it because because there's semicolons and it can separate the parts directly. However, in Python, that is not the case. If you wish to separate your pieces of code, you're going to have to press an enter, and for stuff in indents, you're going to have to press a tab. I will get to that part in a bit, more about indents and tabs later. First off, we got to install Python, and we also got to install your IDEs. IDEs stand for Integrated Development Environment, or is that what they stand for? Let me just check real quick. When in doubt, always Google. Integrated Development Environment. Yes, indeed, that's what it stands for. So yes, IDE stands for Integrated Development Environment. Essentially what this means is that you have a bunch of tools where you can use to create your code. It usually features plenty of stuff, including yeah, Google will be your best friend for programming. And yeah, I'll try and be the best. I'll try and be the second best friend, I suppose. So yeah, so an IDE usually would contain a text editor, and this is the most important part. A text editor is where you're going to be editing most of your code, and it's essentially where you're going to be writing your code. So essentially, a text editor is a definite must in an IDE. Second thing which you're going to have is probably a compiler, and the third is is a debugger or something. I forgot. No, wait, sorry. Yeah, second is a compiler, and the third is a runner, if I remember. I forgot the thing, but they have a lot. They have a lot of tools and development kits which you have. They even have IntelliSense. IntelliSense is basically the dictionary for codings. Essentially, it will tell you if you made a small mistake, like a typo, or if the program didn't understand what you wrote, or whether if it made any sense in the terms of programming. You're going to find out later on how IntelliSense could save your life, but for now, let's go with installing Python. So right now here I have opened up Python in my web browser. So essentially you're going to go to python.org, or you can just simply type python.org on the web page directly, and you're going to go to downloads. And now here's the thing. Now you can download the latest Python version, for Windows. I'm using Windows, so there's also Python for Ubuntu. I think a couple of other Linux distributions, and obviously Mac too. But here's the most important thing about this. Do not install the latest version at any time. Like Python, you see, because Python, they're more like, while the latest releases are certainly do have many different functions, you're not going to be using any of those functions as a first year engineering student. In fact, uh, the more functions you have, the more complicated a Python code can be, and sometimes they're often complete overhauls with certain functions and all that sort of stuff. So it can, like, different Python functions may differ from different versions. And sometimes some Python versions may have more functions. Sometimes some Python versions may not have a function. It depends on the Python version and what it stands for. So for you, I would assume first year engineering students would usually install Python 3.6. And so that's what you're going to be downloading, the 3.6.8 if you are on Windows. That's what we installed as Windows users. So just go scroll down to 3.6. Oh, there's 3.6.13. But just simply install 3.6, go to 3.6, and then go all the way to 3.6.8, the last bug fix release. This is what you're going to be downloading. So select that, and there we go. Okay. Oh, right, not in the download section. I went into the release details, but don't go into the release details. Go into the actual stuff itself. So looking for a specific version. So go down, scroll all the way to 3.6.8. If I recall, 3.6.11, I believe it's somewhere around here. 3.6.9. There we go. 3.6.8 released in December 24th, 2018. Select that, and there are multiple files which you can download. As a Windows user, and I'm using a 64 web-based version, so I guess we can select the executable and I don't know what the web-based version is, but sure. Since I have a 64-bit architecture for my CPU, I can install the 64-bit executable. Save as, and sure, downloads. So wait for the download to complete, and in the meanwhile, we can go into Visual Studio Code. As a first year engineering student, you would be using Visual Studio Code as your IDE, although it's not technically an IDE. It's Visual Studio Code is more what we'd call a text editor, essentially. Now, there are other text editors as well, which you may have heard, called, for example, you have Atom, and a couple of others. For example, well, Notepad++, that's a text editor. You can certainly use that. And there are many different text editors which you can use. But for your purposes, and because you don't know how to compile a function or like run the thing directly through the interpreter itself, you will be using Visual Studio Code, and you're going to be installing a couple of add-ins. So, and yeah, so what is Visual Studio Code? So Visual Studio Code, as I said, is a text editor. It's good enough with the right add-ins installed. And this will be used by instructors to teach you, and they will be teaching you on it. It's very lightweight, it loads incredibly fast, and I do recommend this as the main go-to text editor. However, at times, sometimes the text editor may fail at certain points. For example, installing certain libraries, that you can have some headaches installing certain libraries, especially through Visual Studio Code, often which I recommend swifting to another IDE, but we'll get to that later. So first off, Visual Studio Code. How do you install it? Simply type up Visual Studio Code in Google. I already have written it. Go to the first link, and there we go, download for Windows. There are also other versions with, for example, Macs, Windows, and the Linux versions, DEB and RPM, if you prefer using Linux, your choice. So if you're going to be downloading Visual Studio Code, I recommend downloading the stable version and not the insiders version, because the insiders version is essentially a beta testing and it would have bugs. So always download the stable version for uh, uh, Visual Studio Code. So select the download documentation already, and there we go, save as, and yeah, just simply select save, and you're installing. So I already have Python. I just have downloaded Python. So let's open it up, install it. If it runs, oh, there we go. So oh yeah, I already have Python installed. Let's just modify it. Now the modification essentially would be your installation here. So here's what I recommend. Select all of these. Select next. And precompile standard these you usually do not need, but if you wish to install them, just select all, installing. Oh, and during installation, you're going to have another option called add to path. It's not shown here because I already had 3.6.8, but if you see the add to path portion when it comes up, like for example, I'm pretty sure it shows around here when you're installing it for the first time, add to path. When it comes up, always remember to add to path. If you do not add to path, then Python would simply not work. Like you're gonna have a hard time installing libraries and doing a couple of other stuff. So always remember add to path. Like always add to path for Python. Just remember to select that checkbox. And I have just installed Visual Studio Code, but I already have it installed anyhow. Just follow the installation process. If it opens, there we go. Microsoft Visual Studio, I accept the agreement, next. So you can select, so you can choose whatever you want, and also remember this one too also has add to path. So remember, select that add to path all the time. And next, you know, the other stuff. I already had it installed, so I'll just simply leave it for now. So now Visual Studio Code is installed and Python is installing. Oh, I already have another one. Let's close this. So yes, installing, updating, pre-compiling a library. It takes a bit of time. Depends on how long you want. Now, yeah, so we have Visual Studio and Visual Studio Code installed. So while we're waiting for that to install, I suppose I can go through what Visual Studio is. Visual Studio Code. Visual Studio Code. I'll get to Visual Studio in a second. Wait on it. So opening up Visual Studio Code, somewhere around here. There we go. And it instantly loads very quickly. And this is running off a HDD, by the way. I didn't install this on my SSD. I'm running this off an HDD, so it's very quick. I have a C++ file open right now. That's not what I need. Close that. And so when you open it up for the first time ever, trust this window, manage, trust. Okay. So right now, I have Visual Studio Code open on me. When you open it up for the first time, this is what you're going to be seeing. The first thing which you want to do is to install some add-ins for Visual Studio Code. And I recommend getting the following add-ins. I have a lot of add-ins, and C make all this stuff. These are all C++ stuff. But for Python, the things which you'd want to install are Python. For example, this, you can simply search up the extensions in Marketplace, Python here, and it will show up on the thing. So here we go, Python, installing, and just install the Python directly. Python for VS Code, Thomas. This is appears to be an extension pack. Python language pack. Not really that useful, especially not for what we're going to be doing right here. So there we go, Python, and yeah, it's being installed right now as we are speaking. And so there we go, and you have the Python extension pack. Now you can choose whether if you wish to install these or not. These are essentially just extra bits for Python for Python code. You have IntelliCode, for example. This one essentially would tell you, like, see, for example, if you're typing something in Python, it would immediately quickly uh, write it for you. It's very similar to Kite if you've used that before. But yeah, actually, you know what? I think I'll install this one too. This one seems pretty nice. So yeah, you can choose which ones you install, but Python is a definite must. You need to install, and extension pack is the second thing which you can install later on. You can add more extensions. For example, what extensions do I have? Let me close that, and so yeah, better comments. This one essentially allows you to create your own syntax for your own comments. I have this installed because I love color coding my VS Code, my code very well. So yeah, you can if you wish to install that, run that. This one, Code Runner, very useful, especially for running code. This one, oh yes, Code Runner. This is the second thing which you'd want to install. If you wish to run your Python code, then Code Runner may be is a high recommendation. Just get Code Runner, and this will allow you to, you know, run your code essentially. And I'm not so sure whether if Python itself already comes with a Code Runner, but frankly, if it did, maybe congrats. If it doesn't, no problem. Just download it, and it essentially would allow you to run your Python code. It essentially will run the Python shell. It will run the Python interpreter, and you can just simply select that. It's going to run the your particular code. It also can run your C++ code and other codes. You can see what codes it supports: C++, C, Java, JavaScript, PHP, Python, Perl. So many different Pythons. Then you have Jupyter Notebook. I really never used this, but Jupyter is a very good resource for Python. I really do not know how to use Jupyter, for example, so I have it installed. If you wish to use it, go ahead, but don't know. Code Spell Checker is another good extension which you might want to use. It's essentially basically a dictionary. It is a dictionary. It's kind of like Word. It works very similarly to Word in the sense that it's going to fix your spelling. And it saved my life more than I'd like to admit, because I type quite fast and I make quite a lot of spelling mistakes in the process. And so sometimes I may have written like for example, when declaring a function, or when declaring when declaring a variable or anything, I may accidentally write the variable name wrong, and then afterwards write the correct spelling later on, and then only to realize that, hey, the correct spelling isn't working, and you're just scratching your head, why isn't it working? Well, then code spell checker would be able to fix your spelling mistakes and whatever mistakes you have in your code. So highly recommend it. At least for me, it was very useful. Discord presence shows you that you're working on your project on Discord. Basic stuff. Oh, Draw.io. I think I already spoke about Draw.io in the sense that it allows you to create very professional drawings and diagrams, especially for memory diagrams. You're gonna know what memory diagrams later on, but they are very useful in terms of drawing professional looking diagrams. And yeah, if you wish to go, you can get the Visual Studio Code add-in, or you can simply download Draw.io directly from just simply typing Draw.io download, and yeah, that's it. Excel viewer views Excel sheets, or you can, because I can't be bothered to open up Microsoft Excel, so have an add-in for that. What else? Remote WSL rewrap, a couple of other stuff which I use for other things. So let me enable Python. And there we go. When you select the install Python, then it's gonna tell you to install Python. The Python requires an Python extension to be installed. Install Python from the Microsoft Store. However, we already have Python, so we can just simply go to, install a Python project. Or wait, it's get Python for data science. I mean, it's been a long time since I ran Python, and well, so apologies if I do something. Python version. Well, mark done. Screw this. So yeah, there we go. And so you have so over here, now you have the essential parts complete. You have the essential Python parts complete. Has it finished installed? There we go. Yep, finished installing. So, so let's create a new project then. So you can select one of these options, or you can just simply select File, New File. Actually, let's close this. First off, we need to open a project folder. So let's open the folder first. Open folder. And I have a lot of stuff. Let's just open it up on desktop. Test. New folder. What should I call it? Hello world. That's now, yeah. Now you may ask, why am I writing hello world for my first ever Python project? And this is because trust, yes. Yeah, it's a classic. Yeah, hello world is essentially basically the first ever code every single new programmer begins with. Every single time you start a new project, or like every single time you begin learning a new language, the first thing you always run is hello world. It's a tradition, and traditions should be kept, so try and follow traditions. So yeah, Visual Studio Code has now this annoying feature where it says, "Do you trust the authors of this?" I mean, I know it's very it's for security, but yeah, it gets annoying sometimes, especially if you're opening multiple folders. So yes, and I trust the authors. Select that, and there we go. So here we are in the welcome folder. We can close this because we don't need it, and you can see this section over here. Now, hello world, we have hello world open. This is the folder. Now folders over here look like this. They have the drop down menu which show you which describes the folder. So we can add another folder in the hello world itself by selecting another folder, but for now we don't need that. We just simply write hello world. Now let's create our first ever Python file. Python files have the extension of .py at the end. So we can write hello underscore world .py. Now you may ask, why am I using an underscore for my file names? And that is because sometimes some programming, some OS and some other programming languages, or some programs themselves may not recognize the space because for some random reason it doesn't. They may consider the space as some other character. However, that's why usually the underscore is often used as the space over here. So always remember, for file names, I really recommend you use underscore as the space. So if you're going to be writing your UCID and then your name, for example, my name is Kazi Mushfik. So if I were to write Kazi Mushfik over here and .py, this would work in Windows. However, sometimes some of the older generation programs or older programs may not recognize the space in between because they're old. They may consider them as separate folders completely. So they may even just consider this this file as simply mushfik.py because space Kazi is ignored. So that's why I always and a second thing is, try and keep them small letters, small caps, because sometimes capital letters are also sometimes not recognized with older legacy code. So try and stick with small letters and underscores for spaces. So hello underscore world .py. There we go. Hello world. And now we have our editor open. Now we can run this directly, but before we run this, first off I'd like to run this empty thing first. Like, we haven't placed anything over here. Oh, let me just my mic just I'm using my phone as a mic, so apologies. I probably need to set that in silent mode right now, actually. There we go, silent mode. So let's start with running the empty project first. Don't type anything yet, just simply make sure that your program and everything is set up correctly. So select run Python file in terminal. or debug Python file in terminal. So you can choose either one of these three options. I actually don't know which one to choose. I think it's run Python file in terminal, I believe. Yeah, there we go. This is the terminal which you would be using for Python. Oh, okay. My bad. Well, you can use both, but well, we'll get to that later. So first off, you're gonna have to check which Python version you are. So if I remember, I forgot what to do. So how to check? So we can simply when in doubt, always Google how to check Python version of VS Code. When in doubt, always, there we go. So there we go, run the following command, Python 3 hyphen version. So Control C. And yeah, that's another thing. Why am I opening up Discord? There we go. So yeah, it's very simple. Now you may wonder, why is it Python 3? That's because the Python version which we are using is Python 3 point something. Python 2 is an older legacy version and is no longer supported. Python 3 is the next generation and it's used more widely in most applications. So there we go. We typed in Python 3 hyphen version. Run that, and it didn't seem to work. How do you want to open this file? Oh dear, it appears I opened up another file. Okay, maybe not. Maybe not run the Python file in the Python terminal. This is running Windows PowerShell. Excuse me, why am I running Windows PowerShell? Delete PowerShell. We don't need Windows PowerShell. Run code. Okay. Code. Why am I running Windows PowerShell though? Delete. It's been a long time since I last used VS Code, so apologies. And it's been a long time since I last, what do you call it? Why am I running Windows PowerShell here, though? Okay, what if I type it directly here in the console area itself? Would it work? No, apparently not. Print. Would this run? This should run. Oh, Control S. Always remember to save your code before running, otherwise it's not going to run. Oh, there we go. So it did run Hello World. Okay, so would this work then? Fuck's sake, what the hell, man? File cannot be accessed by the system. What am I even running? Okay, so, what if we run Python directly? Okay, Python 3.6. And there we go. So this is the terminal, Python terminal, which you would see. We can directly type which Python. Isn't it always like that? No, it's not actually. Before Python actually had the terminal thing, or VS Code used to have the terminal thing directly, and you can directly access it. For some reason, I don't know why I can't seem to access it. Maybe the younger generation could, but whatever. There's always a workaround for this, and in this case, simply just load up the Python version directly, and it is absolutely hot in my room. Damn it. All right, there we go. Much better now. So in your Python terminal, type up Python 3 version, space hyphen version, enter. Traceback Python 3 is not defined. Interesting. Or is it CMD? CMD stands for command prompt. Is it that? Python was not found. Huh, interesting. And here I have the 3.6-bit. Okay, apparently it's not recognizing my Python, but it's there. Oh boy, I'm gonna have a hard time installing libraries at this point. Which is why IDEs are there, and I'm gonna show you how to use an IDE later, because screw this. So yeah. Ignoring that, let's just go back to the normal. Is there something there or something? Is it just me, or is there a small... No, it's not just me. What's that? What is that thing? Is there like a small box over there on my screen? What is that? Did I type it or something, or what? What is that? Okay, okay, fine, I'll just ignore it for now. So, yeah. Okay, where was I? Hello world. So, yeah, apparently I wasn't able to find my Python version. But you can clearly see I have Python installed. So, stuff happens, this stuff happens regularly, and you just gotta do with it. Deal with it, I guess, in a way. So, yes. Anyhow, so you installed Python, you installed Visual Studio Code, and this is it. Hello world.py and print. I can't zoom in. What is this? So, and print hello world. That would be your first ever code. I recommend this to be your first ever code because it is tradition and it is where we will start with for Python. So yeah, and you can see that there is no semicolon at the end, as I said. It's a very simple code. You can very easily understand it. It says print. Essentially, what it's telling the interpreter is to print to the console this value over here. And you can even read the description over here. Prints the value sys std out by default. And the sys std out is essentially the terminal which you're talking about. This is what it's called. They're called terminal. So yeah, you can even choose which stream it can print to, but that you're going to be taking in other courses and in a higher level, in a way. So I guess this is where. So yeah, that's hello world. And so now you have installed Python. You have installed VS Studio, Visual Studio Code. Now, what is the next thing you're going to do? I'm going to teach you how to debug Python, how to debug your code. Or I'm going to try and teach you how to debug your code. What is debugging? Debugging essentially is forming sort of like trying to find the memory place, like where each memory location is. Now, you have to understand programs usually assign memory or assign memory slots into their memory area sort of thing. What do you call it? Yeah, programs are stored in memory. And by memory, I usually mean the RAM or whatever other memory device you have. Most likely you should have RAM. You probably use RAM for your laptop. But yeah. So if you're going to by storing it in memory, that means you're going to be storing it in, like, you can access it immediately. And that's what we mean by storing in memory. Now, we can also see what we stored in the memory directly. Instead of just simply knowing that, oh, we placed this program in the memory, we can also tell the details exactly in that program that have been stored in the memory. For example, I simply wrote hello world, but I can also have variables and functions. Now, what are variables and what are functions? You're going to learn them later on, but variables are essentially, well, variables. You know how you have x or y. Like in algebra, you were told that x or y can contain any sort of random value. Variables are something like that. However, you actually assign a proper value to a variable. So for example, let's create a variable. And the good thing about Python is that you don't have to follow a generic structure. It's very lax, and there's barely any rules in terms of how a variable should be created. So you don't have to use you have to have some very basic rules, but compared to other programming languages, you can be very relaxed. So let's say we want an integer variable that contains let's say 75, and we call that variable x. So how do we write that in Python? We write int, that stands for integer. What else? Yeah, x, that's the name of the variable, equals 5. Oh, sorry, 75. Statement must be separated by semicolons. What? Did I make a mistake or something? Have I actually forgotten how to do Python? How to use Python? What? What's that? Assigning variables in Python. There we go. Did I actually forget how to type Python? Oh, okay. I remember now. Yes. Okay. Good news. Python does the what do you call it? The assigning of what type of variable it is for you. I completely forgot about that. Right. So now in most other languages, a data type is essentially the type of data it is. That's what we refer to as a data type. So int is a data type. It stands for integer. Double is another data type. It stands for, well, it's a bigger data type. It can store about 8 bits of data in C++, depending on the processor really, or whether if it's 64, 80 or 32-bit. But that's some extra stuff. So yeah. Where was I? Yes. So double is another. Regain my connection. Hello, I just lost my internet connection an hour ago, and I just regained connection. No problem. This entire session is recorded, and I'll be uploading this session up onto YouTube later on. So don't worry, even if you missed it. So don't worry. The video should cover, the recording should cover pretty much everything you need to know. Now, where was I? Right. Data types.
Thank you.
No problem. So data types are essentially, the type of data it is. So you can have int, which stands for integer, double, which stands for 8 bits of data, float, which is, you can have decimals. You can also have decimals in double, but takes more space. But in your area, in the low level programming, because you're just starting out to programming, you don't have to focus on too much on the differences between double and float. Just know that double is bigger than float. That's all you need to know. And yeah, so you have different types of data types. In most programming languages, you will have to define the data type before assigning a variable, and that data type cannot be changed throughout the course of your program. So if you assign x, a variable x, as a data type, and you assign it as integers, for example, in most other programming languages, you usually type int x equals 5, and then you add a semicolon like that. Now you can clearly see over here I already have multiple mistakes, well, only one mistake really, and the semicolon is highlighted red because you're not supposed to use a semicolon in Python, but we're doing some heresy right here. And now the main reason as to why this is the case for most programming languages, or at least it's the case for Java and C++ and C. However, in Python, you do not need any of that. You can remove the semicolon and you can remove the int and just simply type x equals 5. And the program and the interpreter actually would automatically realize, hey, x is an integer and it has been assigned 5. Now, you may have a question. How do I know whether if something is an integer and if something is not? Well, simple. Integers do not contain any decimal points, but other values do. So if you have any other value, for example, if we type 5.3, well then congratulations, and Control S, well then congratulations, X is no longer an integer, but now it is considered as a float. And a double. Do doubles exist in Python? I'm not too sure. I think it's pretty much, I think it's only float and integers. Do doubles exist in Python? They're almost the same, so there is no such differences between a float and a double. Okay, there we go. So apparently a double type does exist, but they are almost the same, so much so that to the point in which there's basically no differences. So yeah, there's a bit of trivia for you. If it ever comes up, I guess you know the answer to. They're basically the same thing. So now, so I'll stick with the more correct term. I'll call this float because, you know, floating value. Uh, how do I describe this? It's floating value contains decimal points. I guess that's all you need to know. So 5.3, it's a decimal. It's now a float. So y equals 3, and now that's the second value. Now notice that in other programming languages, you usually can store them in the same thing. You usually separate them with a. This is what I mean by separating them with a semicolon, and this would work. And actually, it seems to have worked in Python just now. That's interesting. I've never noticed that. So you can use semicolons in Python, apparently, in a single line. Actually, I probably shouldn't be showing you this sort of stuff because it's going to confuse the crap out of you. So forget about that. Forget about what I just showed you. But y equals 3. So this is how you're going to be writing in Python. If you have two separate things, separate them with another line. Always like what you see over here. So always separate your lines. Always separate, like, you know, always for your variables. It's considered good practice, good programming practice. So there we go. We have two variables, and now we want to know what memory does each of them take. Like, we want to know what does the memory contain. Actually, let's do a very simple arithmetic first before we actually go into the debugging part. Let's take x plus y. All right, and let's assign a variable for that. Z equals x plus y. Now, normally you're going to be typing x plus y equals z, but over here, remember, we are assigning variables. When we are assigning variables, we always type the variable name first, which is x, y, and it doesn't have to be just simply letters. You can also have like proper names like hello. That can be a variable name, or hello, or kzi. That's hkzi. That's kazi. That's another variable. You can also have capital letters, kazi, or small letters, which you saw over there, or just a random assortment. But the stuff you cannot have are numbers. I mean, you can have numbers, but that's only, you cannot start with a number. You cannot start with a number in Python over here because that's not allowed. That's considered wrong. It's going to give you an error, and you can already see that it indeed is giving me an error right here. So Python, you cannot start with numbers. You cannot also start with special characters, and by special characters I mean percentage signs and all that stuff, because these are operators, and you cannot start with an operator, unfortunately. Well, not unfortunately, fortunately, because otherwise it's going to get confusing as all hell. So yes, no numbers. You cannot start with numbers, and you cannot have any special characters in them. But that does not mean you can't have special. So you can have underscores. Underscores are certainly allowed. However, not minus characters. You can't have operators, and percentage is indeed an operator. You can't start with a special character, or can you? Underscore, yes. Okay, so you can start with some special characters, for example, underscore and all this stuff. Basically, special characters that aren't used in used in calculations and all. And majority of them are, as far as I can see on my keyboard. So yeah. So you can start with an underscore, but you cannot start with a minus because that's, it's considered minus, or you can't start with a hyphen, that's what it's called, because, it's considered minus here. However, you can start with an underscore. There we go. So we can type in, you can have numbers at the end though. So you can have KAZI underscore 3. Oh, sorry, not that's plus 3. That's wrong. Underscore 3. So you can have KAZI3 or like, any of the thing. You can have stuff like that, but you cannot start with a number. Always remember that. And yeah. So where was it? Yes, Z equals X plus Y. Let's add some space for, for readability. You don't need to have any space for these sort of things. Like operators don't need spaces. But, just keep spaces for the sake of it. It looks better, makes your code look a lot better. So there we go. Now we want to find what is the value of Z. So we can type print Z, and this will be printing Z out onto the console later on. But what if we want to know what is inside Z before? Because this is a very simple arithmetic equation, you can tell. However, you can easily see how we can have very complex equations where there are multiple variables containing multiple different things, and you want to know what does each of them contain, or what does one contain. So over here, let's say we want to find out what Z contains before we even see it in the terminal. There are two ways in which you can do this. Number one is that you can directly print whatever is inside that variable. However, that takes a lot of time, and you're going to have to figure out where the print even occurs, and if there's a mistake, it's going to take a very long time. The second method, which I highly recommend, which I use personally, and which pretty much every single other programmer does, I mean professional programmers that is, they use the debug method. Debugging essentially means looking into the I think I already defined debugging, but I'll define it again. Debugging essentially is looking into the memory and the specific part of memory, and looking at the addresses and looking at what that address contains. So in this set over here, we have multiple things, and we can when we run the debug option, we can see that we will find that Z contains that. However, so let's go select run and debug. Oh, first off, remember, you see this circle over here at the top? This means it isn't saved. Remember, Control S, always save your work. Otherwise, it will simply run the previously saved work. If you're going to be compiling or running it through the interpreter, it's simply going to be running the the pre-compiled thing. It's only going to be.
Please can you show that again?
Or autosave it. Unfortunately, you can't autosave it. So always, so in order to save it, Control S. That's what I'm pressing. Control CTRL plus S. That's Control S. That's what you usually press to save. Or right click, and the save option should also be here. And yeah, and I do not know whether if there's an autosave function on this. I don't think there is. Maybe if you save it on OneDrive, there may be an autosave function, but as of now, I can't tell whether if there is an autosave function. So I can't seem to find the save function over here. File, yeah, there we go, save. Select save, and there we go, you saved your file, and you can see that it's the circle disappeared. That means this is the latest version, it has been saved.
Kazi, go on to file again. File, and then autosave.
Oh.
I think it autosaves.
Oh yeah, there we go. So it automatically so it's apparent. Yeah. So there we go. Autosave is now a function. Apparently, it doesn't need exist. Thanks, Yash. By the way, for those of you who don't know, Yash is a second year, just like me. He also suffered through first year, but now we're second year, so nice. But yeah. So there's the autosave function, which apparently saves everything you want. So good for you. You can select that, have that enabled at all times, especially I can see it being very useful. But I just got used to pressing Control S so many times that I'll just press Control S for the sake of it. So where were we? Yes, we have our function. Let's go and try and hit debug. And there we go. Select Python file, and oh no. What just happened? It appears that it didn't even debug. What do you think, Kazim? And that is because we didn't put any breakpoints. Breakpoints are essential in debugging. What are breakpoints? Breakpoints are essentially like telling essentially like kind of like a point in the code where it tells the debugger, hey, stop right now. I want to see the memory access or the memory location or the memory addresses of whatever is inside this place, inside this particular code. How do you add a breakpoint? So it's very useful, and it's very useful for extra long pieces of code. For example, let's say you have like a code that's about 700 or 800 lines. I made a 700 or 800 line code. Now, if you were trying to debug it and it goes through each and every single line, it's going to get really annoying really quickly, and it's going to take hours, maybe even days, depending on that. So that's why, yeah, if you debug and you go through each and every single line, it's gonna get annoying really quickly. Thankfully, most debuggers often give you the option, give you breakpoints. Breakpoints tell the debugger to stop immediately. How to add breakpoints? If you see the number over here, you have the space in between, you go to the number and you can see that a sudden red dot just appeared on the side. You go away, red dot disappears. This is the breakpoint. This is indicative of where you want the breakpoint to start. Right now we're at line number 6, but line number 6 is where the print value. We don't want the breakpoint here. We want the breakpoint earlier. So we're going to select over here breakpoint at, and there we go, breakpoint at over here, and you can see the breakpoints over here if we bring that up. If I can bring that breakpoints. How do I drag this up? Or we can do that. Sure. So yeah, breakpoints are at the top. You can see hello world.py and raised exceptions and other stuff. Breakpoints, these are also automatic breakpoints where it just like says that in the event that if you have any errors in your code and you try to run it or run and debug it, then it's gonna, it's gonna stop. But most of the time, that shouldn't be the case. So here you have breakpoints. Let's add another breakpoint. Let's put it at X, let's put it at Y. And so that's why we can see how our code works or how memory is stored from the program into the memory. So now we can select run and debug and wait for it. There we go. This is the function. Now, the yellow line shows what is about to be run, like the code that will be run just now. So now you may see all these different options. Now, the only options that you need to consider are the step over, step down, and stop. Step over essentially is go line by line, go into the next line. So even if you don't have a breakpoint at y over 3, if you select step over, then it's simply going to go on to y over 3 anyhow, because it's going to go line by line. Step down, step into, sorry, it's called step into. Step into basically means it's going to go into the next breakpoint immediately. It's going to ignore whatever stuff is in the middle. I'll show you an example later on when we have a slightly bigger code. And stop is, well, stop, and restart is restart. So there we go. Continue is basically that. Oh no, wait. Oh no, sorry, my bad. Step into, yeah, sorry. The thing that goes into the next breakpoint, the stuff that goes into the next breakpoint is continue, not step into. I actually have no idea what step into and step out are, as a matter of fact. Never used them before in my life. No idea what they are. If you manage to figure it out, congratulations. Have a cookie. But I don't. Never was useful for me, so we'll go there. So continue will go onto the next breakpoint immediately, ignoring everything that's in between. Step over essentially would go line by line, and restart, stop, basic stuff. It's very simple. Now you got to understand how the debug thing works. You have the terminal over here that shows the debug console too, which is about to be run. And so you have the terminal over here. The yellow line, which is indicative over here, essentially shows the code that is about to be run. It hasn't been run yet. Don't think that just because it's highlighted means it has been run. No, it hasn't been run yet. Remember that. Debug only stops the thing immediately before it gets run. All right? So that's what the breakpoint does. It stops it just before the code is run. That particular line of code is run. All right? So we step over, and there we go. It just like, we just ran x equals 5 over 3, 5.3. And you can see that something has been added over here onto our console. Special variables, what are those? Ignore those. So over here you have your variables and everything else. Variables essentially show you what you have in your stuff. You have globals, but you don't... Oh yeah, because we're in the global area, okay. You're going to understand what globals are and locals are later on, but that's in a later part of your course. I'm not going to explain it to you now because, the professor will explain it to you later. This is only the basic of the basic stuff. So, yeah. So here we have variables, locals, and globals because it's considered global. I'll not explain it now. Ignore globals. Just focus on the fact that x.3, 5.3 is shown up, and x equals 5.3. That's the value stored in x right now. That's the value stored in the variable, and that's the variable stored. That's the value stored in memory right now. Now we're about to run the second piece of code, which is y equals 3. Now, if you focus back over here, you're going to notice that we run it and y equals 3. Y is now 3. That got stored into the variable section. So you can start seeing how the debugging a code, the debug thing will be very useful later on. Now here we have z equals x plus y. Now we do not know what z is. We were not given any information. We do not know because we haven't even initialized it yet. So x plus 5, this is going to be the value. So the value of x plus 5 will be stored in z. This is essentially what we're telling the compiler right now. So we step over, we're about to run z equals x plus y, run that, and now we get the value of z, which is 8.3, and indeed that is correct. 5.3 plus 3 is... No, let me just open my calculator. 5.3 plus 8.3, yes. You can't never be too sure, right? So yeah, 8.3, and if we print that, indeed we get 8.3 as the output over here in the bottom of the terminal, and that is indeed our answer. So there we go. That is how you debug. Now I'm going to be showing a bit better of an example. Let's have some more stuff. Let's say q equals 8973, and actually let's have some words too. Why not have some words? Indeed, if for variables you can also store letters and words into into a variable. So we can say word equals hello. And here's one thing which you might want to pay attention to is the fact that I haven't simply wrote hello. I wrote hello in quotation marks. Why did I write that? That is because if I remove the quotation marks from hello, then it's going to give me an error. It's simply going to say hello is not defined, as it's thinking hello, or whatever this word is a variable. So if we don't include the quotation marks, then it's not going to be registered as a word, but rather it's going to be registered as a variable. So remember that if you're going to be registering a word or a sentence or anything like that, always remember to have the colons or semicolons right beside it. You can also have singular colon. They're not colons. Speech marks, I think. They're called speech marks. Why have we been calling them colons? They're called speech marks. Congratulations, Kazi. My first language is English. English is my first language. Sorry, English is my first language, and my English is this good. You see, this is what engineering does to you. Your English just goes to crap. Goes to all hell. So yeah. So there we go. Word equals hello. What other stuff should we have? What equals... We can have quotation mark, and now we can even add numbers. And the classic foo equals bar. All right, there you go. So now we have multiple breakpoints, and we can start. We can put a breakpoint here and here, I guess. All right, now I'm going to be running this thing again. Run and debug. And there we go. It stops immediately right before x equals 5.3. Now we can select step over. We already saw what step over does. It's simply going to move on to the next line. For example, this one does not, like for example, line number 2 does not have a breakpoint, but if we select step over, it's going to go on to, it's going to run the first line, and it's now about to run y equals 5.3, step over, so we can go line by line over here, like that. That's what step over is. Run and debug again. X equals 5.3. Now what happened? Now we're gonna select continue. Continue is gonna move on to the next breakpoint, and you see you skipped all of this. You're gonna skip the initialization of y equals 3, and you're gonna skip the initialization of 892, and you're gonna skip the initialization of x. You're gonna skip all of that. It's good. They're gonna show up. Obviously, they're gonna show up over there on the variable section. They will always show up, but you're just simply gonna move on. You're gonna skip on to the next thing. What does what and foo mean? What and foo are variable names. They're simply variable names. To the computer, this is no different than x or y or z or q. This is no different. They're just simply variable names. And in programming, it is highly recommended you give your variables proper names. For example, if you're gonna have a variable called altitude, and it contains the values of altitude, or you can call it ALT, short for altitude. So always give your variable names meanings. All right, what to the computer, what and foo are simply variable names. To us humans, we recognize them as something else, but over here we're gonna have to think like a computer. We're gonna have to acknowledge that these are just simply variable names, and they do not have any meaning on their own. They're just, names. So yeah, hopefully that answered your question, right? Does it, or do you want me to explain a bit more? All right, good. So yeah, we can skip on, and there we go. We skipped all of that, and notice this. Here we have the word hello, and that's because we stored hello into the variable section. However, notice that it is declared yellow over here. All right, it's orange, not yellow, orange. It's declared orange. Why is that? You're gonna find out a bit soon. You're gonna figure that out a little bit later, but right now that's not important. Just know that it, like for words, especially for strings, yes, this data type consisting of all these letters and all, they're called strings. So you're gonna learn more about these data types later on, but yeah, strings are stored differently, and they can be accessed differently compared to normal variables, but you're gonna learn about that later. So yeah, that is how you debug. And if you use this properly, if you follow through, if you use this properly, then it can be a very powerful tool that can even help you in your exams. It helped me through my quizzes. It helped me through my assignments. It saved me a lot of time. So it can also save you a lot of time, especially if you are smart with the debugging, essentially. So yeah, we can stop that. And yeah, that essentially is how you debug using VSC. So save, Control S, we can close this, I suppose. Next, we can start with other IDEs. The next best IDE, which I would recommend, is called PyCharm. Now, Visual Studio Code is excellent, and the instructors will use it most of the time. However, as you can see right now, I had a difficult time trying to access the terminal for Python from Visual Studio Code, because it's essentially just supposed to be a text editor. It's not something massive where you can immediately access many different things at once. It's a text editor, and with the right add-ins, maybe you can possibly access the terminal directly, but right now we're just having a hard time, and frankly, I couldn't be bothered to figure it out or debug or do it myself. So what am I going to do? I'm simply going to move on to PyCharm, and PyCharm is actually going to help me do so many things because it's a proper IDE. It's a proper IDE. This is simply a text editor that's pretending to be an IDE. It's like it's an imitation. And for I guess as a starter, this is an excellent starter. You need to know how to begin with code because an IDE does everything for you. It's kind of like spoon feeding you. However, it's far better to start with Visual Studio Code, and in the final projects and all, just move on to the IDE proper IDEs later. And what do I mean by the proper IDE? I'm talking about PyCharm. So go up here, select PyCharm, PyCharm, the Python IDE for thing. Now, the good thing about this, this is part of the JetBrains IDE series. Now, JetBrains offers impressive, incredible IDEs. However, most of them are unfortunately paid, except PyCharm. PyCharm is a community fully free. It's free to install, and it's yours forever once you install it. I have it installed and I love it. And they have so many different things, and it looks really nice. I just love it. So you have many different things. You have intelligent Python assistance. It comes with web development, scientific tools, whatever that is, remote development, and built-in developer tools. And this is why it's called an IDE. It's one of the best. So you can figure out how to use PyCharm using the welcome video, but I'm just going to give you the basics of it. It's because you already saw how Visual Studio Code worked, and frankly, any other IDE works very similarly except in the sense that they have more tools. So here we have the professional version, which is a free trial. Don't buy this one because it's only a trial. Go for the free, built on open source. Go for the community-based one. And frankly, because the community one has more than everything you need. You don't need anything more than the community. So select that, hit download, and yeah, it's gonna immediately start downloading over there. If you wish to have tips and tricks and all this stuff, you can enter your email, but for me, it's just extra spam. Who would want that? So I already have installed PyCharm before. It's 127 megabytes. It's gonna take a bit of time to install it, so I'll just ignore it for now. I already have it installed anyhow. So PyCharm. PyHarm. Yes, we're harming Python. Charm. This is the community edition. I haven't updated it in a while though, I guess, so it's probably going to tell me to update it. Takes a bit of time because I'm running it off HDD, and it is a proper IDE, so yeah, excuse me. I guess we can close this for now. There we go, PyCharm is loading. It's loading on my main screen because this is my primary screen right over here. Don't have it on my second screen, so just wait for it, I guess. It'll come eventually. I guess I shall eat my dinner because I haven't eaten it yet. So, yeah. Oh, there we go. Right. Let me drag this here. So there we go. This is what you will see when you first run Python for the PyCharm for the first time ever. So there we go. Update. Let's just update and restart. And right now it says no interpreter in the corner. And this is what you're going to have to do. You're going to have to set up the interpreter. So select interpreter, and there you go. Because now notice that Python 3.6 is there, and that is because it was added to path. If Python was not added to path, oh yeah, another thing, PyCharm would also ask to be added to path. Always remember, every single time you get the option to add to path, always select add to path. It's gonna make your life a whole lot easier instead of trying to find out where in the world that thing is. So over here you can clearly see that because I added it to path, Python 3.6 is already added over here, so we can select that. I don't need to restart it right now. It's interpreting, and now it's updating skeletons. Just take a bit of time it's been a long time since I last started this, so there we go. So let's open up file, open, and yeah. Let's see, where do I go? Where's my folder? Well, I can't seem to find it, so I'll just go to D. Personal files. It's not others. It's probably. Okay, maybe it's not here. Maybe it's in university. Maybe it's my OneDrive. Yeah, there we go. OneDrive. Personal codes. There we go. Python. Python. That's one. So we can select that. And we can open it up in this window. So select that up, open up in this window. And there we go. This is a sample Python script. So main.py. So now if you just select it, it's going to say no Python interpreter for this project. Use Python 3.6. There we go. All right. So there we go. Python is integrated, and now we can simply run this thing. So now you may notice that all these gray text over here, these are comments. And comments are exactly what they are. They're simply commenting code. They're essentially just, snippets for allowing you to comment on your code. Commenting is very important, and I highly recommend everyone to comment on your code, so that's way you can understand what you are. What you're writing, and other people could also understand what you're writing. So commenting, please do it. It's a sign of good, good programming skills. I comment a lot. I love commenting, and it really is useful. Documentation, you're going to have to comment a lot, especially if you're taking ENSF 337 or ENCM 335. Commenting, you're going to learn how to comment. You're going to learn how to do documentation then. But yes, in Python, a comment is usually is signified by having the hashtag symbol. So this is a comment, and when it gets run through an interpreter, the interpreter will ignore comments. So anything that starts with the hash will immediately get ignored. If the Python interpreter will go through line by line, obviously, and then it's going to see the hash, it's going to ignore that line. And comments are really useful, very useful for me in this case scenario. I can't even spell that. What so we can have print hello world, and yeah, you can see that the style is a bit different now. What do you call it? The text is now in green over here, and comments are gray. In Visual Studio Code, the comments will be green if I remember. It depends. Different IDEs and different code editors have their different styles, so you can choose. So, oh yeah, another good thing about PyCharm is the fact that you do not need to install any plugins. The only plugin which I really installed was I think it's something about spell checker. I think I installed a spell checker, and I also installed the Discord rich presence, so my presence is shown on Discord, like people can see me on Discord. That's my Discord presence. So over here, it's very similar to PyCharm. It's very similar to VS Code. However, this is a bit more advanced because you have more tools, and it's going to be a bit more advanced. It looks a more advanced, but trust me when I say it's the same exact things over again. You have the files, project files over here. You have the terminal and the Python console. Oh, and this is good because now you can directly run the Python console, and because you can run the Python console, you can directly run it over here, and you can see, because PyCharm is good, and it really helps you. And another thing which this can do is that the fact that if you're using custom library functions, then it will automatically recognize those functions, and PyCharm would give you an option to install those functions. Back when I was in first grade, when I was doing the we called it ENDG 233. When I was doing 233 back in your grade, we were trying to install this library called NumPy on our computers because we needed NumPy in order for the program to run. However, it was a pain and it was annoying, especially when you try to install through Visual Studio Code, because first off, you're gonna need the command line or whatever you call it, the terminal, and that had so many issues because sometimes the Python version wouldn't just show up for some random reason. Who knows why? Even though it's on path and all this stuff, just for some reason, Visual Studio Code hates Python for who knows why. That's why once you get a feel for how to edit on code, I highly recommend you just simply move on to PyCharm immediately the moment you like after week 6 or week 7, all right? Just move on to PyCharm because when you start doing more advanced stuff, PyCharm is going to save you. It's really going to save your life. But for the first few weeks, recommend going with Visual Studio Code, so that's so you can have a feel for what the instructors are doing. And you can understand more about what the instructors are doing. But yeah, that's how stuff works here. And over here, it's very similar things, basic things over here as well. You have main.py, which is the main Python file. You can have multiple Python files, and you can also learn how to add them together, like how to have them connected to each other. I'll learn that later on in about week 11 or week 13, if I believe. So yeah, here we have our Python file. The debugging part of it is very similar. Again, to the right over here, it's a bit different because on Visual Studio Code, you have the number first, and then you put the breakpoint. Over here, the breakpoint is placed before, but the same red circle is there, so you can understand that this is indeed a breakpoint. And it's even going to highlight it in red, so you can very clearly see which line is in a breakpoint. So this is one of the extra tools. Also, you may see this line over here. You may wonder, what is this line? This line is essentially to let you know that, hey, you're writing a bit too much in one single line. For example, this is more useful for comments really and just normal code, because most displays wouldn't have a big display like mine. I have a 1080p monitor. However, most displays might be a bit smaller. So that's why when they're a bit smaller, sometimes the code may get cut off at the edge. And so it's gonna get annoying, just to scroll to the side, all this stuff. So that's why by having this imaginary bar, this is essentially an imaginary bar over here. By having this bar, you can easily know when you need to move on, when you would want to move on to the next line, or when you would want to shorten your code. It's an automatic shortener. It's very useful, especially if you want to keep your code neat and tidy. You can also know how many lines you've used over here. I forgot which one it is. Okay, so this is okay. So 124. This means the first number stands for which line I am at, and 24 is the number of columns, or which column I am at over here. So space also takes up a character, or actually, yeah, over here it shows how many characters are over here. So space indeed is also another character. Tab is 3 characters, 3 spaces, and in one. So there we go. So yeah, and that's essentially it. There you have a breakpoint. I suppose we can start. Would you mind writing the meaning of the breakpoint in the chat? Right, so I already explained it before, but the breakpoint essentially would cause the program to stop. A breakpoint is essential for debugging, because if you try and debug without a breakpoint, the program's not going to find any place to stop at, so it's just simply going to go all the way through, and you're not going to debug anything. However, having a breakpoint there means you're telling the program to, hey, stop right here. I want you to give me the details of whatever is happening here. Give me the memory details of whatever is happening over here. Breakpoints are very useful in programming. It saved a lot of lives, and it saved my life. You can watch the recording later on to understand. I gave a better description on what a breakpoint is a bit earlier. You can watch the recording later on if you wish. But yeah. So again, breakpoints are very similar. For debugging the program, you have the run function. You go to the side over here, you go to the top right corner, and you have the run option, you have the debug option. And you can also select which Python file you'd want to have. And right now I only have one Python file, which is main. So that's the only one that's showing up. If you have more Python files in the folders area, then it's going to show up over here as well. And you can select which one you want to run. So right now I only have main, don't need anything else. And you have the run option. The debug option is the one with the bug, classic. And if you select the debug option, then you have all these options again. Very similar, resume and stop and restart. So resume, stop, restart, and I'm pretty sure the step over. Yeah, this one is the step over. So the step over is placed on a separate place. It's not with the thing. It's placed over here. This is step over, as in it's gonna go. It's the same function. It's basically this. It works very similarly to Visual Studio Code. It's just that it looks a bit different, but in terms of functionality, it's very similar. And you can see all your variables here and where they are and all that sort of stuff. And another advantage is that because this is more advanced IDE, if you have multiple files, if you have multiple Python files and you have them connected to each other, and you would wish to see the breakpoint, and you have a breakpoint in one, and you want to see the value of whatever function there is on another file, you're going to understand what I'm talking about later on. Just so you know, this will have the multiple files open too, so you can easily select which file to open up and see where in memory is each thing located, so you can easily debug your program, you can easily see where you went wrong. So yeah, that's how you debug your program. And that is it. That's PyCharm. That's PyCharm, which is the best IDE. I highly recommend you use this. This is the best IDE in my opinion. And yeah, that's about it. If you wish to install, well, I mean, you can easily see the welcome video in order to understand how to use PyCharm or set it up and all this sort of stuff. Setting it up is very simple. Don't need to do much. And that's about it. Yeah, I guess I shall stop recording.